This will be lesson 1 of chapter 6. In this chapter we'll talk about chemical bonding. In the previous chapter we talked about individual elements, and here we are bringing the elements together to form compounds. So the first thing to say is that there really are 3 general types of compounds possible, and we're going to take a close look at 2 of these types. The first type is your metallic bond. The second is something called an ionic bond, and you can hear the word ion in there. These will be made up of ions. And then the third type is called a covalent bond. Now, in all 3 of these types of bondings, when the atoms come together, so here's one atom bonding with the other, it's important to remember that it is the valence electrons that are reacting. On the outside of the atom, it is the valence electrons which are interacting. The inner electrons actually do not interact, is the idea. So we'll be looking at these valence electrons. Let's take a close look at the metallic bond. In a metallic bond, the valence electrons are what we call delocalized. By delocalized, we mean they're everywhere. They're not localized. They're not stuck to a particular atom. They can actually go anywhere they want in the whole arrangement. So they move around freely, is the other way of putting it. In this case, what you see, these clouds, these reddish clouds, are clouds of electrons. And these electrons can go anywhere they want throughout the whole arrangement of metallic atoms. And this is why metals conduct electricity so well. They pass along these electrons really, really easily. Here is another static picture of it. You can see the little valence electrons, the outside electrons that are free to move. And the metallic, essentially, the metals are ions. So again, electrons are free to move anywhere they wish. And this is why metallic compounds have the following properties. They can conduct heat and electricity. We talked about this in the previous chapter. They are what we call malleable. This means they can be easily deformed. You can actually hammer them into sheets and make them into any shape you want. If you want a pipe, if you want a block shape, you can make metals. They're soft enough to where you can deform them. Now, some metals aren't that soft, but if you heat them up, they're easily deformed. They're also ductile, which means they can be made into wire. So copper wiring is used in electronic devices and so forth. So that's why metals can be shaped so easily, is because of this. Electrons can be anywhere they want, and atoms don't really belong to each other, if you would. So the second type of bonding is ionic bonding. In ionic bonding, it's a different type of scenario. Here, there is an electron that's transferred. Ionic bonds are the transferring of electrons from a metal to a nonmetal. Now, it's important to be able to see why. Remember that metals have a very low electronegativity, which means they don't want electrons. Nonmetals, on the other hand, have a high electronegativity, which means they really love electrons. So when the nonmetal and the metal come together, the metal essentially will give up the electron to the nonmetal. And that's exactly what you see happening in this case. So the sodium atom has this one valence electron on the outside. The chlorine atom wants one valence electron. So the sodium will actually give up its valence electron to chlorine. In the end, sodium, having lost an electron, will form a +1 charge. Chlorine will form a -1 charge. And these then come together to form your ionic bond, famously in sodium chloride. So this is the most famous ionic bond, sodium chloride. Now, because of this strong charge that results, ionic compounds are solids at room temperature. And they're solids because they have such strong bonds, essentially, around the ions. They have high melting points, high boiling points. It's really difficult to melt an ionic compound. So here is what an ionic compound would look like. Very hard salt, essentially. Very hard to melt it. You have to have a really high temperature flame to melt these. Now, these conduct electricity. Here it says, if dissolved, but not in their solid form. Now, metals would conduct electricity in their solid form, but in this case, because this is made up of ions, positive and negative ions, when they're together, these positive and negative ions essentially cancel out. But when you dissolve the, say, salt in water, the sodium ion and the chloride ion come out, and now, because of their charges, because essentially you can think the metal is now free, the sodium can now conduct electricity. That's one way of thinking about it. So when they're in their compounds, they're not free, they're bonded together, they're held together, but when you dissolve them, they're free to move, they can then conduct electricity. Okay? And finally, let's talk about covalent bonds. Now, covalent bonds form when there is a sharing of electrons. And this happens between nonmetals. The reason it happens between nonmetals is because think of two nonmetals. Both of them have a high electronegativity, so both of them really desire electrons. Well, one won't give up the electrons to the other one because both of them want electrons. So they will end up sharing. They'll decide to share electrons. So both of them have the advantage of having extra electrons that they want. And in this case, what you see is you see carbon, the element carbon, sharing electrons with the element hydrogen. And in fact, carbon shares this electron. These are carbon's electrons. Carbon has 4 valence electrons, if you take a look at the periodic table. And this electron is actually hydrogen's. So hydrogen is actually willing to share one of its electrons with one of carbon's electrons so that together they can form a stable bond. I know it's a bit messy, but essentially these right here are the electrons that are shared between carbon and hydrogen. And the reason elements do this is so that they can achieve, as we'll see, a noble gas configuration. That is what every element wants to do. Now, electrons can be shared. One pair of electrons can be shared, or 2 pairs of electrons can be shared. Actually, up to 3 pairs of electrons can be shared. So here are 2 atoms sharing 2 pairs of electrons. You can say this pair belongs to this atom belongs to this atom. They decide to share both. In some cases, you need to share more to become like a noble gas. So this is the case with covalent bonding. And so compounds that form from this type of bonding, called covalent compounds, are usually liquids or gases at room temperature, which means it's easier to separate them than it was to separate ionic compounds. And they have low melting boiling points. If you have a low melting point, that means you're probably already a liquid. If you have a low boiling point, you're probably already a gas. So things like oxygen, for example, or carbon dioxide, for example. And these do not conduct electricity, whether they're dissolved or undissolved. And you can think of it, they have no metals. That's a rough way of thinking about it. It's really, the reason is because they don't form charges. But they have no metals, so they don't conduct ever. Remember, ionics conducted sometimes because they're made partly of a metal. And then here you see a liquid, and here you see another liquid, a famous liquid, acetone, that we'll come into contact with. Okay, so to summarize, here's a picture, and we'll leave you with this in this first lesson. Here is an ionic compound. This is sodium chloride, the famous ionic compound. Here is a covalent compound. These two really are the ones we're going to study in much more depth. Ionic compounds look like this. They look like alternating ions. Here is your chloride ion, and the purple one is actually your sodium ion. And it's essentially a conglomeration of these ions. And that's why ionic compounds form these nice crystals. If you can find them in nature, they'll actually very often come in these clean crystals. Covalent compounds, on the other hand, don't have this. What you have is you have individual units of sharing electrons. So this oxygen, this one is an oxygen, this one's a hydrogen. They are sharing electrons between each other, and so they're bonded together in that way. And you get individual units here in covalent compounds. We'll discuss this together more in the next lesson, but this completes for us lesson 1 of chapter 6.